Name of the experiment: determine the potential energy of a spring. Here we know that potential energy equals to half kx square, where x is the change in length of the spring after adding load. Here one table is given, number of observation. We are taking 1 2 3 4 5 observation. Initial length of the spring we are taking y1 in centimeter. Now load on spring m in gram. Then after loading, the length of the spring is y2, so extension x equals to y2 minus y1. Then potential energy equals to half kx square. Then we will take average PE. So here I have taken one reading, that is the initial length of the spring 14.9 centimeter, and I have placed 200 gram load on the spring. Then after loading the spring, change in length change to 41 centimeter. So extension equals to y2 minus y1, that is 41 minus 14.9, so 26.1 centimeter. Now if I put all the values, then at first spring constant k equals to, we know that f by x, so we know f equals to mg by x. So here mass is 0.2, 200 gram equals to 0.2 kg, and value of g is 9.8 divided by x, that is 0.261 meter. Here extension equals to 26.1 centimeter equals to 0.261. So spring constant equals to 7.509 Newton per meter. Now we put this value in the formula, half kx square, so half into spring constant 7.509 into 0.261 square, so 0.255 joule. That is the potential energy of the spring. Here is a figure is given. So initial length, that is the y1, then after adding load, length change to y2, so x equals to y2 minus y1. Apparatus of this experiment is, we need a spring, a stand, and there is a clamp with a meter rule and load. So here is the initial length. Here is another reading, that is 8 centimeter, and I am placing here load. Then its changes length is y2, that is 13.5. So if I subtract these two value, then we will get the change in length. Again, we are determining the potential energy of a spring. Here we know that potential energy equals to half kx square. K is the spring constant. We can find the value of k equals to f by x. We know f equals to mg, so mg by x. M is the mass and g is the gravitational force. So here at first we need to take the initial length of the spring, that is the y1, and load on spring. Then after adding load, change in length is the y2. So if we subtract y2 minus y1, then we get the extension, then potential energy, then average potential energy. So if we put the value on, this value is given here, initial length of the spring, then final length of the spring, then extension, and if we put all the value in potential energy equals to half kx square equals to half into 0.7.509 into 0.261 square. And in this case we need a spring, then load, then a stand and clamp, and a scale.